the first applications are probably not as important for somebody studying business, but it gives you the idea of what this is. So remember, we're going to do one business application at the end of this, but just to kind of give you the idea, rates have a lot to do with travel, like, velocity and acceleration and stuff like that. Related rates problems can be difficult if you don't follow a certain procedure. So one thing I'm trying to do when I do these problems is having you go through a certain procedure. And what we typically have on this is, typically what you have is you might have a problem where you're given one rate and then you're finding another rate that's related to it. Or you might be given two rates and you're finding another rate like that and so forth. So this problem that I'm going to do to start with is doing this. Now this is just to give you an idea of what related rates is primarily. You're going to do something like this in your homework, and the ones that I do in this class are not going to be quite as messy as the ones that I do in a science major calculus class. But the first thing with this is, let me read the problem and kind of let's think about what's going on in the problem. So it says you have a ladder against a wall, and then the ladder is sliding down at 2 feet per second. So that ladder is going down. You're going to find at what rate the bottom of the ladder moving away when the bottom of the ladder is 10 feet from the wall. So let me explain what this is saying, okay? So what's happening is, and this is really the purpose of this problem, is to start and kind of get your head wrapped around the equation, the process of related rates. Okay, let's just say the ladder is sliding down, okay, at some rate, okay? So what if, as the ladder slides down, what happens to x? It gets bigger, okay? So if the ladder goes down, that goes out and eventually it's on the ground, right? Okay. So there's a tendency sometimes students will think, well, if I know this rate, then that rate's the same. Not necessarily, okay? It all depends on the mathematics. So the idea is I'm going to give you this rate. You're going to find this rate based on that. So typically what you're doing is you're relating derivatives, and anytime you're dealing with rates. So one of the things you always want to do, and these are the steps you want to go through carefully, because if you don't, you'll struggle putting this together, because they're word problems, and the thing that students struggle with word problems is putting it together anyway. Okay, so we got a picture. I just took this picture out of the book here, and first of all, one of the things you want to do is you want to see whatever equation relates the variables, and you always want to write down what you're given in the problem, okay, like this. Okay, so what we have here is we have a right triangle. So it's background. You guys would have to tell me if you know how the sides of right triangles relate to each other. Do you know that?
A equals 9 squared.
A squared plus b squared equals c squared, the Pythagorean theorem, right? Okay, so you got to deal with the Pythagorean theorem. You're going to do that quite a bit in this section. I think most of the problems are going to revolve around that idea, okay? So what we're going to have on this then is, you remember the Pythagorean theorem goes like this. You have the, usually you write like A is a leg, B is a leg, and then C is the hypotenuse like that, okay? All right? So what you would have is you would have A squared plus B squared is equal to C squared like this. So when we write this equation down, it's going to go like this. These are the legs, so you're going to say x squared plus y squared equals 26 squared. Okay, so you need to get that written down. That's the general equation that relates these variables. So we're going to do something with that. And you can go ahead and do 26 squared. We might as well get that out of the way. And that's going to be 676 like that. Okay, so this is going to be pretty straightforward on this example. If you have a diagram, you got to know how to relate those things. Okay, now here's the part that students sometimes don't do well with, is knowing what you're given and what you're trying to find. Okay, so first of all, it says that this is a real key right here. It says the top of the ladder is sliding down the wall at 2 feet per second. Okay, that's a rate. Why is it a rate? Because it says feet per second. Okay, that's a rate. That's the rate that you're given. Now, what is the variable in this? If it's sliding down the wall, is that y or is it x? Y is the measurement of down, up and down, right? So what you're going to say on this, when you start writing down what you're given, you got to write this in terms of Leibniz notation. So one thing you're given is dy over dt, and it's dt. These related rates problems have something to do with time. That's typically the way it's going to be. Okay, that's going to be 2 feet per second. But since it's going down, we're going to model that with a negative number. So I'm going to write that as negative 2 feet per second like that. That's what you're given in the problem. That's one thing. Okay? The other thing you're given, there's one other piece of information. It says you're going to find the other rate when the bottom of the ladder is 10 feet from the wall. Which variable tells you how far you are from the wall? X. Okay? So that means that X is going to be 10 feet. Okay? Now we can use rates as negative or positive. Okay? That thing is going down. That's why I'm using that as a negative number. Those are the two things that you're given in the problem. Okay? Now, what are you trying to find? So it says, at what rate is the bottom of the ladder moving away? So if it's a rate, you're talking about Leibniz notation, dx dt, dy dt. So is that going to be dx dt or dy dt? Dy. No, dx, okay, because that way is x, okay? So what you're trying to find, this is what you're given. The unknown, what you want to find, is you want to find dx over dt. Okay, and you need to start these problems this way. I mean, you need to write down literally what you're given and what you're finding, or you won't do these well at all. Okay, so we got everything that we need. We've got our equation, and then we've got this. Okay, now there's one other thing that we're probably going to need to do on this, and that's something with the Pythagorean theorem. So I'm going to do this kind of up here. All right, we got our general equation, but really what we're looking at is if this is 26, the ladder's always 26, right? That's not changing. But we're interested if that was 10. So we need to use the Pythagorean theorem to find y, because that will be another piece of information that we're really given in the problem that we have to find. So we'd have to do the Pythagorean theorem. You would say a squared or 10 squared plus b squared is equal to c squared. And you would have to solve that equation for y. 10 to the second is 100. 26 to the second was 676. You could subtract 100 from both sides. And we'd have y to the second now is equal to 576. Okay? Square root both sides. And do that on your calculator. Is that 24? Somebody do that on their calculator. Is that right? 24, is that right? Okay. All right, so that means y is 24. Okay, so that's what we have so far. So let me kind of go over what I've done so far. Pythagorean theorem, everybody got that? Know that from their background? Okay, you got to know that for this section. This is what we're going to work with the calculus on, is this. And then I was given the rate going down. That's why I said dy over dt. That's why I put a negative. Okay, you got to make sure you do that notation. You were given 10. That was given. We had to find that by the Pythagorean theorem. The question is find the rate that it's going this way. That's x. That's why I have dx over dt. You're always going to have dx over dt, dy over dt, dz over dt, like that. That's what you're going to have. Okay, now here's what you do. Now that we've got everything set up, we're going to take this equation. You want to go ahead and write this equation down, but we're going to do the derivative with respect to t of both sides. You're always going to do that. That's what the related rates problems are talking about, rates with respect to time. So we're going to do implicit differentiation on the problem. That's why we learned it. Okay, so what we'll have then is, let's go ahead and do the derivative now. All right, so what's the derivative of x squared with respect to t?
2x.
Okay, yeah, you got to be careful. Okay, it's 2x, but the variables do not match, right? So you have to say dx over dt. What are we trying to find anyway in this problem? Dx over dt, so it better be in your equation. Well, now it is. That's good. Okay, what's the derivative of y squared?
2y times d over dt.
Dx over dt. Okay, almost. That's good. Okay. Then the derivative of 676? 0. Okay, so we got that. Now see, we're going to solve that equation for dx over dt. Okay. Now one thing that you can do on this is you can factor that out. You could also factor a 2 out if you wanted to. So the common factor is, and you don't have to take the 2 out, but you can. You might as well. If you don't, you're still going to work out. So let's take a 2 dx over dt out. Okay, and then when we do that, you can just kind of block that off in your mind, and what's going to be left is going to be x plus y. Okay, so we have x plus y equals 0 like that. Okay, now what do you need to do? You need to get dx over dt by itself, so what do you need to do? Oh, hold on. Did I do something wrong here?
The g over
Hang on. What in the world did I do here? Oh, no. Let's see. I think I'm okay. Hold on just a second. Now what we're ready to do is we can plug in the particular information. Okay, so I've got this. Now you might as well just plug everything in now because we know everything. Okay, so what we're going to have is a 2. X was given. Okay, look at the problem. X was 10. Plug it in. Okay, so that's going to be a 10 that goes there. dx over dt we don't know. That's what we're trying to find. Then we have 2. Okay, then we have y. Okay, see, y in this problem was 24. We found that. Okay, and then dy over dt, you were also given dy over dt. That was -2. Now that's equal to 0. Okay, now let me kind of go over that because I kind of confused myself, which probably means I really confused you. So here's the idea. Okay, if I do this derivative, the variables don't match, right? That's 2x, but dx dt. Okay, this is 2y dy dt. That's what I messed up on. Okay, so everybody got that? Got to have the same variable. Now, I know these things. X, I knew. X was 10. That was given in the problem. Dx over dt is what I'm trying to find. And over here, y, we found that. Remember when we did the Pythagorean theorem? We had 10, 26 already. We found 24. And then dy over dt was the rate you were given. So that's it. Okay? Does that make sense? Okay? Now, we need to solve this for dy over dt. So now it's pretty simple. That's going to be 20 times dx over dt. Okay, if you multiply all this out, that looks like that's going to be minus 96 equals 0. So you're going to have that. I just do the arithmetic. Now you can add or move the 96 to the other side. So you'll have 20 times dx over dt equals 96. And then what? Divide by 20. And then you want to get your calculator on this and see what you get there. Okay, and that's probably 4 point something, I don't know, 4.8, yeah, that's right, okay, 4.8, okay, so that would be that rate that we're trying to find is 4.8 feet per second, okay, so when you do this, then, of course, it's also important to kind of write the answer the correct way and then be able to try to reason through the problem. So what this says, how far did they say the ladder was from the base of the building? At the beginning of the problem, what did they say? 10 feet, okay? So we found the ladder is moving away at a rate of 4.8 feet per second. And then the units are going to work out. I mean, the units are kind of designed so that they work out.
Where did you get the other 2 from?
Okay, tell me which 2 you're talking
So
about.
you got 2 times 10 plus 2 times 24 times -2. What was the -2?
Okay, that came from this, okay? Right there, because if you look at my thing right here, what did I do? I did 2 times y. Y is 24, that was good.
Right, I got you.
And it was negative because it was going down. Okay, sorry about the little slip up there. Sometimes it's hard to see a little mistake like that. Any questions about what I did? Okay, all right, let's push on and work a little bit more of this then. Okay, so this one is going to be very similar. It's got another variable though. So this one what it's saying is you have two motorboats that are leaving from the same point. They're leaving from this point right here at the same time. One travels north at 15 miles per hour. Is that a rate? Yes, okay, so we've got a rate. Okay, that's a rate. Okay, now let's talk about what that rate is. Which variable is talking about distance north? Y. So that means that dy over dt is what? 15. Now it's positive because north is positive. So that's something you're given. So you have to write this Leibniz notation correctly or you're going to struggle. So that's 15 miles per hour, okay? That's what that says. Read on, okay? It says the other travels east at 20 miles per hour. Is that a rate? Yes. Which rate is it? Good, dx over dt. X is the distance east, so that means you also have dx over dt is equal to 20. Do you think positive or negative?
Positive.
Positive. You're going to the right. It's positive. Okay, you got to be careful with your negatives on there, okay? Then it says how fast, let's look at what we're trying to find. How fast will the distance between them be changing in 2 hours? Well, first of all, another unknown is time is 2 hours. Okay, that's what that is, okay? Now, remember, you're trying to find a rate. How would you write that rate? What is that rate? dz over dt, because it says how fast is the distance between them changing, and that's z. So what's happening, everybody agree that as the boats move, z is getting bigger. Okay, all right, so we got that. So what we're trying to find is dz over dt. Okay, that's what we're trying to find. So remember, when we get our equation and put it together, we better have dz over dt in our implicit differentiation, see, okay? So we got most of that. Now there's a few other things that we're going to have to figure out as we go, but let's see if we know what's going on this. And again, this is a right triangle, isn't it? So you're still going to have the same thing, okay? You're still going to have Pythagorean theorem. How would Pythagorean theorem go on that? X squared plus y squared equals z squared. Everybody know the hypotenuse and what that means and everything? That's the longest side. That's the side that's opposite the right angle. So that means we're going to have x squared plus y squared is equal to z squared. Okay, that's what we're going to differentiate when we work with this then. Okay. Well, first of all, on this problem, you got to remember we also kind of have this. So this rate here, if you read this rate right here was 15. And remember, you have distance equals rate times time. So you need to know that. If you have a speed of 15 miles per hour and it's taking you 2 hours, well, then how far did you go?
30.
You went 30 miles, right? So that's 30 miles. You got to figure that out. Okay, then the other boat, its rate, I think it said, was 20 miles per hour. So this one, you're going to do 20 miles per hour times the 2 hours. That's going to give you 20 miles. Okay, so you have that. 40. See, look at me. I'm doing bad things today. Gosh. Just checking. Okay, so we got 40 miles like that. All right, so we have that. Now you could figure out this distance right here by the Pythagorean theorem, couldn't you? See, the 2 hours is going to tell you how much those distances are. Does that make sense? Rate times time. Okay, we'd have to do Pythagorean theorem. So you'd have z squared equals 30 squared plus 40 squared. So that is z squared equals 900 plus 1600. So that's z squared equals 2500. And then you could do square root of both sides, and I think that'll give you 50. So 50 miles. Okay, so now we've got some other pieces of information that we know. Okay, so we actually also know in this problem that x is 30, y is 40, and z is 50. Okay, like that. Okay? So that's kind of where we're at with this, okay? You got to be able to carefully write down every little piece of information we have, get your equation, and then know what you're finding. Okay, does that make sense? Are you guys following okay?
I think X had to be 30 and Y had to be, Y.
Yeah, X is 40.
Yeah,
Y is
X
30.
and Y is.
Oh, I got my variables backwards, don't I? See, I'm getting sloppy. It's almost the weekend. Okay, so we got, let me get that. Y is 30, because that'll mess this up if I'm not careful. X is 40, and then I had Z is 50. Okay, now I'm good. Okay, all right. Okay, now let's go ahead and let's work with this now. What we're going to go ahead and do now is differentiate this with respect to t. So on your step 4, what you're doing is you're going to do d dt of x squared. This is where I messed up on the last problem. Then this is d dt y squared. And then this is d dt of z squared like that. Okay, so let's kind of get that put together then. Okay, now I'm going to be careful this time. Okay, what's the derivative of x squared? 2x times dx over dt. Okay, what's the derivative of y squared? 2y times dy over dt. And then what's the next one? dz over dt. Okay, right? Now remember, what we're trying, see what should happen is that's what you're trying to find. You should know x, we know x. You should know dx over dt, we know it. We know y, we know this. We know everything except dz over dt. So that means you can plug everything in now. Okay, so let's go ahead and kind of carefully do that. Okay, everybody with me on the derivative? Okay, start plugging things in now. Okay, so it looks like x was 40. Okay, dx over dt was 20. Okay, then we have 2 times y. Y was 30. dy over dt was 15. Okay, z was 50. Then we have dz over dt like that. So you're going to know you're messing up. If you don't have all that given information written down, you're going to know you're missing some part of that problem. So then we'd have to just kind of calculate and then solve this for dz over dt. So if I do...
Z is 50, right?
What's that?
2 over
Yeah, you said
50
0,
times
5.
Yeah, 50. There we go. Okay, thank you. Okay, 2 times 40 times 20. I probably should have just stayed in bed this morning. We got 2 times 30 times 15 is 900. Then that's 100 times dz over dt. Okay, and then this is going to be, that's what, 2,500 equals 100 times dz over dt. And then what do you do?
Divide by 100.
Divide by 100, good. Okay, so if you do that, you'd get 25. Okay, so you'd end up getting dz over dt is the rate we're looking at, is 25. And this was what? Miles per hour. Okay, that's the answer. Okay, so there's a lot of work involved in identifying what you have and getting that equation put together. So the way you would write the answer is like this. It said in 2 hours. Now it's a part of what you were doing. You were given that 2 hours later, the distance between the boats is changing at a rate of 25 miles per hour. So the thing is, those rates are dependent on the other 2 rates that you're given. Okay, so as those 2 boats move, that's the rate at which that distance is increasing. Okay, you guys follow what I did? This is oftentimes a real hard thing for students to learn. Even in my other Calc 1 class for science majors is a real challenging area. What do you think? If you follow the steps, that's one of the reasons that I'm trying to do on each of these examples is, write down every step. You got to kind of go through this step by step like this. Make sure you have every little detail down. Okay, I'm going to do this one, and then we'll finish up with the business application. Yes?
So the rate, so when you got z is 50, you know, you just do the rate times time and divide by 2 and you get 25 that way.
Say that again.
Why didn't you just, when you got z is 50, why you just do rate times time equals distance and divide by 2 and figure out the 25 rate?
Well, I had to get, I'm not sure exactly what you're asking on that. I needed to find, because 2 hours was certainly a part of it. So I needed to go ahead and find these distances of 30, 40, and 50, because those are imperative parts of the problem. Because, I mean, the problem would change at 3 hours. At 3 hours, those distances would be further and further, wouldn't they?
I think what she's saying is like we already knew the rates for A and B, so per hour. So couldn't you just find the distance for C or Z, which is per hour, and then just multiply it by how many hours you're looking for?
Don't think so.
Alright. I mean, we knew the rate was 50 for 2 hours. So could you not imply that it was just 25 an hour?
Yeah, I mean, it would kind of go like this. The other thing you can kind of do in here, now I heard you say divide by 2. Now, one thing that you could do right here, in this part of the problem right here, you could divide everything by 2 there. It wouldn't change the answer in any way. So, I mean, because all those things are all have a 2 in it, so that could be divided by 2, and then you could have that equation. So, I mean, you're dividing by 2, you could do it earlier in the problem right there, but ultimately you got to have that equation built right there. So you can do that divide by 2 later, or you can do it there. Okay. All right, let's look at this one. Okay, now this is again just kind of one more example to kind of get you on a kind of a handle of what's going on. Now this one would be an algebra background thing that you might not know. You're given an equation on this one. You're given x to the second plus y to the second equals 25. And what that is that's a circle. Okay, now I took this one out of the book. This is how that goes. I do need to review this a little bit. So anytime that you have this, now if you don't know this, you need to make a note of this. That's the equation of a circle that has a center of 0, 0, and then the radius. That thing right there is the radius. So what happens in the problem I'm giving you is it has that structure. So the center is 0, 0. The radius is not 25. The radius is 5 because 5 squared is 25. Now, you may know that from college algebra or finite math, or you may not. If you don't, that's something that you need to make a note of. So this is the graph of how that goes. And so you got a center of 0. Then I went out 5 on that radius. Okay, like that. All the way around the circle, you have a radius of 5. Okay, so that's what you have. Now, that's the equation you're going to be working with because I gave that to you. You don't have to figure it out like the last examples. Okay, so the equation that's going to relate these variables is given. Now, if you read on, we have a point, -3, 4, and that's on this circle. So notice if you did x squared, x is -3, and you did y squared, you would get 25. That's pretty easy to see in your head. 9 plus 16 is 25. So that's a point on the circle. Okay? Now, okay, what it says is this right here. You got to read what you're given in the problem. So it says its x coordinate is increasing at a rate. That's a rate, right? Okay. So how would you write that? Remember, it always has a dt in it. What do you think? It says the x coordinate, dx over dt. Good. Okay, so that means that you know dx over dt is equal to, and it says it's increasing, so I'm going to put a positive to stress that. If it was decreasing, you would want to use a negative, and it's just units per second now. So that's what that piece of the problem says, okay? I've also given you x and y. Okay, that's given in the problem, so let's write down that we also know that x is -3, and we know y is 4. Okay, so we have that. That appears to be all we have in the problem. Now let's figure out what are we asked to find. How fast is the y coordinate changing at that moment? So what are you trying to find? dy over dt. To me, that's the key to doing related rates, is to be able to write this language correctly in that Leibniz notation. That's what you're trying to find, is that right there. So we have identified everything we were given, and we know what we're trying to find. The equation that we're going to use was given as x squared plus y squared equals 25. Okay? Everybody okay? Okay, that dx dt, all that notation is very imperative in these problems. Okay, now what we're going to do is we're going to do the derivative of this equation. So we're going to do derivative of x squared. We're going to do derivative of y squared. And then we're going to do the derivative of 25. Now I'm going to let you guys try to take it from there and see what you can do. Okay, you need to finish that derivative and then try to plug in the information on that. Remember, you're trying to find dy over dt. So if you can do this successfully, then that at least means you got the calculus part done. So go ahead and finish your derivative, then plug in the information that I gave, and then try to find what dy over dt is. So I'll give you a couple minutes to see if you can complete that. Okay, so let's see kind of what we got here. So, okay, make sure you got your derivative first. So you're going to have 2x times dx over dt. Make sure you got that. Okay, so that's where I messed up. So I don't know why I did that either. So this is 2y times dy over dt equals 0, right? Okay, so you got to have that. Now, all of this stuff you know. X was what? Negative 3. Dx over dt, yeah, you know that too. That was 0.4. Okay, then you have y, you know y was 4. Then you have dy over dt. So you can kind of tell, okay, you're on the right track. We got the unknown that we need to have. So let's see, if we do this, that's what? Negative 6 times 0.4 is negative 2.4 plus 8 times dy over dt, okay? Then what you need to do is just move the 2.4 to the other side. So you would now have, well, still got a 0. So we would have 8 dy over dt equals 2.4. And then you can divide by 8. And then we'll see if you guys got this right or not.
I forgot the 0.4.
Yeah, it's always something little. So it's hard to see your own mistakes sometimes. So you would have dy over dt equals 0.3, and then you do want to write the units on this. Be sure you write units per second like that, okay? And really, as far as writing the answer on this one's not as important the other ones. It's you can just say on this that the y coordinate, you can say the y coordinate moves at 0.3 units per second on the circle, and that's good enough for that one, okay? I want you to always kind of know what you're really finding in this problem on that, okay? And that's a motion problem. These kind of problems that I've done so far are a lot more dealing with physics, but to me, if you're learning economics and business, you need to understand how rates work, and that's what you're most familiar with anyway, is velocity, acceleration, and stuff like that. Okay, let's go ahead, and I think we can do probably one part of this. I won't have time to finish this, but let's do the business part of this and kind of look at this. And actually, this kind of stuff, to me, this is actually a little easier on this because you're already going to be given the equations. So this time I'm giving you your manufacturing, let's see, flash drives, and you have a cost equation, a revenue equation, and you can find the profit equation, okay? So what we're going to do, if you read the problem, it says you're going to find, it says you're going to end up finding the rate of increase in the cost, revenue, and profit. I'll just do part A to finish this up here. So I've given a cost equation, and I've also given this. I've given you this sentence, which says the production is increasing at a rate of 500 per week. Now that says something. Now production is how many things you're producing. Well, what variable is that?
X.
That's important, X. That's what X is in those equations, okay? So that means that what you're going to have is, if that's X, that's going to mean that that is dx over dt is 500 drives, flash drives, per week. Okay, so that's a rate that the business is doing. They're trying to crunch out this many things per week. Okay, like that. Okay, then it says the next piece of information is it says the production is 2,000 flash drives. Is that a rate or not a rate? No, that doesn't have anything to do with a rate. I mean, that's just how many things you have. But what is that 2,000? What variable? It's X. That's what X is. It's how many things you're making. So that means you're given X is equal to 2,000 flash drives right there. So if you read the problem, that's pretty much what it says that you're given in the problem. Okay, you have that. Now, what are you trying to find on this? Okay, you're trying to find a rate of increase. How are you going to write the rate of increase for cost?
DC over DT.
There you go. Good. That's the whole key. DC over DT. That's what you want to find. Okay, so know what you're given, know what you're trying to find. Okay, now the nice thing on this is you're given the equation. So let's go ahead and we're going to write down the cost equation, which is 5,000 plus 2x. Okay, then what we're going to do is we're going to do the derivative of both sides with respect to t. Okay, so I'm going to do the derivative of this. Now see, when you do the derivative of c with respect to t, technically the derivative of c is 1, but the variables don't match, so you have that. That's really why you're doing that. You're doing a chain rule, so that's just going to be dc over dt. Okay, what's the derivative of 5,000? 0. What's the derivative of 2x with respect to t? Good. Okay, 2 times dx over dt. Okay, so that's it. Okay, so what we have is we have the rate that cost is changing with time is just equal to 2 times dx plus dt. Okay, like that. Okay, so now we just plug in the particular information. Okay, remember, we're trying to find dc over dt. Okay, the only thing we need to plug in for is dx over dt. Do we know that?
Five one times 5.
Yeah. Turns out the 2,000 drives don't have anything to do with this. So we just have 2 times, and then we'll plug in the 5,000 like that. Now this is going to be money now, okay, because cost is money, right? So it's going to be dollars per week. So that would mean that we're getting 2,000, but there's a cost of, what is that, 10,000? No, hold on, I got an extra 0 in there. I keep doing stuff like that today. Okay, all right. So let's see, that's going to be $1,000 per week. And I see the answer to all these is going to be dollars per week because you're talking cost and revenue and so forth like that. Okay?
So then to write it, it would be if production increased at 500 flash drives, cost would go up $1,000.
Yeah, you'd say the cost is, at what, you kind of want to write the production level. You could say at a production level of 2,000 flash drives, the cost is increasing at a rate of $1,000 per week. Okay, that's what it is. Now notice the 2,000 didn't have anything to do with it. Okay, now the next one I think that'll have to do with that. We'll finish this up next time. Now one thing I wanted to say, let me close this real quick about your test. You guys did get a